I'm going to go over page 567, problem number 12. This was not addressed very well in the class notes. And so I'm just going to read you the instruction. It says, in each part, verify that the functions are solutions of the differential equation by substituting the functions into the equation. So in problem number 12, the question is y double prime minus 8y prime plus 16y is equal to 0. And in part A, they have e to the 2x and x e to the 2x. So each of these are y functions. So for the first one, I'm going to look at is y is equal to e to the 4x. Actually, I'm sorry, I just read problem number 11. So it's y equals e to the 4x. So you just want to take, first of all, the derivative of y. So that will be y prime is equal to 4e to the 4x. And then you're taking y double prime. So that is y double prime is 16e to the 4x. And then you're just going to substitute the y double prime, the y prime, and the y back into the function that is given up here. And so I just substituted all of that. So in for y double prime, that is 16e to the 4x. And then for y prime, I have to multiply it by a negative 8. And so that's how you get a negative 32e to the 4x. And then 16y is 16e to the 4x. And you want to show that that is equal to 0. So if you add up all of the terms here, you have a 16e to the 4x and another 16e to the 4x, which is 32e to the 4x, and another minus 32e to the 4x. So the answer is 0. So that's how you'll do the proof on that. Okay, the second one, the next part is a little bit more complicated because you have to use the product rule on that. So you have y is equal to x e to the 4x. So then the derivative of that is the product rule, f prime g plus f g prime. So you get e to the 4x plus 4x e to the 4x. And then when you take the second derivative on that, you have y double prime is equal to, so this derivative is just 4e to the 4x, and then I have to apply the product rule on this. So that would be 4e to the 4x plus 16x e to the 4x. And then I'm just going to simplify that a little bit. Combining these two terms, you get 8e to the 4x plus 16x e to the 4x. Okay, so just like the other part, I'm going to substitute it back into this one up here. And so I'm putting it back into y double prime minus 8y prime plus 16y, and I want to show that that is equal to 0. Okay, so then putting all of that in, here is y double prime, so that will just be this line right here, 8e to the 4x plus 16x e to the 4x. And then to the y prime, I need to multiply everything by a negative 8. So that gives me negative 8e to the 4x minus 32x e to the 4x. And then for the y, I have to multiply that by 16. So that'll be 16e to the 4x, and that is equal to 0. So if you add up all the terms, you end up with 0 is equal to 0. And so that checks. Okay, for the part B on that one, instead of using constants that are just numbers, they're just using a C1 and a C2. Okay, so you're going to treat it in the same way. So I've actually done this in two parts. And so here you have the original one. So y is equal to C1 e to the 4x plus C2 x e to the 4x. So this is just like the first portion that we did. So this is just the basic chain rule. And then on this one, I have to use the product rule. So here's my line for y prime. So my y prime is 4 C1. C1 is a constant, e to the 4x. And then I'm applying the product rule on this. So that'll be c2 e to the 4x plus 4c2x e to the 4x. And then for my y double prime, I have to use the chain rule on this one, the chain rule on this one, and then the product rule on this one. Okay, so this will be 16c1 e to the 4x plus, and this will be 4c2 e to the 4x, and this one I'm using the product rule, so that would be 4c2 e to the 4x plus 16c2 x e to the 4x. So again, I'll simplify that portion. So then in this line here, I'm just going to be combining these two here. Okay, these are the only two that are common. So this one just stays as 16c1 e to the 4x plus, and then adding these two, I get 8c2 e to the 4x plus, and then this one here is 16c2 x e to the 4x. Okay, now I'm going to substitute all of that and put it back into the original equation that they gave. So I'm going to put in y double prime minus 8y prime plus 16y and show that it equals 0. Okay, so since there are a lot of terms, I'm just going to line them up so that I can add them up a little bit easier. So this line right here is my y double prime. All right, so I just rewrote this line here. So that's 16c1 e to the 4x plus 8c2 e to the 4x plus 16c2x e to the 4x. And then in the next line, I'm multiplying y1 or y prime by negative 8. So that gives me negative 32c1 e to the 4x minus 8c2 e to the 4x minus 32c2x e to the 4x. And then for my last one, I'm multiplying y by 16. So that's 16c1 e to the 4x, and I'm just lining it up so that I can add them up easier at the end, minus 16c2x e to the 4x. So now when I add everything up, you get 16, 16, and negative 32. So this part here cancels out. And you have a positive 8 and a negative 8 with this term. And then here is 16. And then, oh, I think I have a mistake here. So this right here should be a positive. Okay, so that should be a positive 16c2 x e to the 4x and another 16 and then subtract 32 and that gives you 0. So then you have proved it.